Hi, welcome to our third HDF clinic, which is all about your questions around HDF. And unless there are any questions up front, let's start with a question that was posted in the forum and we thought was a good topic to cover here today. And the link in the notes that you will receive, the link is to the original forum post, and the author of that post asked on February 9th, he wanted to know, he wanted to copy the contents from one HDF5 file to another, and he wanted to do that in C++, and he just wanted some guidance on how to do that. And that's a great question. Again, in this forum here, we are all learning. There's no question too small, and there will be many questions to which we don't know the answer, but fortunately, this is one to which we know the answer. And basically, of course, in C++, to do this in C++ is great because the amount of boilerplate code that you have to write is much reduced, but obviously you can do that in C. And the C functions that you would use to do that programmatically is called H5O copy. And I just sort of copied the declaration, the prototype here into the notes. I would also mention that there is a command line tool called H5 copy that I encourage you to test because it, in a way, is also wrapped around the H5O copy functionality. And there are some subtle options to which I come back later that you might want to explore before you start writing too much code. It makes sense to take your HDF5 file from which you would like to copy something and then just play around with H5 copy to get a sense of what's possible and what you can do with that H5O copy function. Okay, but the emphasis appears to be on C++, and personally, whenever C++ comes up, we have a great community around HDF5. And also in the C++ area, there are several nice language bindings out there for C++. And one of them is by Stephen Varga called H5CPP. And Stephen is sort of a regular on the forum, and he is also here today. And we invited him to sort of present his solution. In fact, he has two solutions, and I will give him the floor in a moment. I would also mention that if you followed the forum yesterday, he also just published a very nice tool on GitHub that lets you create, if you wish, random HDF5 files, and you can, in a way, pick how extensive in terms of number of groups and data sets and the ratio between those object counts. You have very fine-grained control over that. And it's also based on some interesting mathematical theory from the beginning of the last century. So there are some interesting connections. And on top of that, the name of the German mathematician was Prüfer, the last name, which happens to mean tester in German. And so lots of interesting connections here. I included in the notes an excerpt of Stephen's solution, but I think he will share his screen and walk us through his implementation now. Stephen, are you ready?
Hopefully, can you hear me, Gerd?
Yes, I can hear you.
Thank you very much for the opportunity. Hello, everyone. I am Stephen Varga, the author of H5CPP. I regularly write software in C++, and I would like to share two solutions to the problem, how to copy objects in HDF5 container. So if I can go on and share my screen.
Yes, you should be able to.
Let's take the correct ones.
Bottom right, share.
I think this is the.
Yeah.
Oh,
yeah,
excellent.
I can see it. Looks great.
Something happened. All right. So I promised you two solutions for this particular problem. One of them is a visitor pattern, and this is what you see on the screen currently, and the alternative one is the traditional approach that Quincy wrote somewhere early 2000, and this is the standard H5 copy. We could start with the second one. It's indeed a few liner. There is just a regular entry point for the C++. There is some includes here. What you can actually see is a profiler on the very top. I just did the profiling, so the results are fresh off the stove. Some argument parsing. My preference is this header-only rparse library. There are links to that on the page. And indeed just requires a few lines to parse the arguments. Then you have a program entry point, and this is where it gets interesting. Regularly, you would open the file and obtain a handle to it, similarly to the output. And in this case, we will obtain a handle for a property list that oops, something happened here. Let's go back to the original one. That is, sorry, right here, the property list. So that's just a chain link of some properties. There is a documentation published what these properties are. Pretty much straightforward, straight equivalent what's listed on the C API. And once you have all the ingredients, the handles for the input and the output, then you can just go at the task by passing the property list right here. That will do the recursive call and call the H5 object copy with the right arguments, and it's done. Well, lots of parts are hidden here or abstracted out, and that makes this code small, tidy, and well performing. How well it performs, that we'll look at the profile later. All right. Let's take a look at the alternative solution. This is a visitor pattern, which basically includes some sort of a callback mechanism. And here you can see the actual callback. For the structure that you need to know is right here. Later you can take a look at the details of the past H5O info structure, which is basically just a key ingredient to implement our Lily copy inside the callback. Now, the details are somewhat different from the previous solution in a way that we do not pass the object copy, or do not call the object copy. Instead, we call the visitor function provided by the C API. And similarly, we create some handles some way in these lines that we can pass to the visitor function right here. And that will take care of the actual callback. Now, this is so far so straightforward. We should get some output. And we can examine the output. Great. What I would like to bring your focus on or attention to is there is no C++ code other than the very basics what H5 CPP provides. We are allowed to use arbitrary C API calls. What makes this happen, what makes this possible, is that all the handles internally binary compatible with the C API. And everything is actually done in a compile time with some template metaprogramming magic. Right. So far, everything looks output-wise identical. What the difference is, I'm just going to skip onto my notes, is the actual performance. What we actually can see from the profile results, I'm just going to shift over to the to rendering mode is much similar in terms of performance. So we can see one of the profile and the other. So what we have to actually look at is the areas here with different colors. They are pretty much matching. Most importantly, you do not see any H5CPP code here. All of the code is, the majority of the area of the code is taken up by the C API calls. So far, everything is good. But once we take a look at the details, what I've just actually noticed is a significant difference in terms of size. Whereas the object copy pattern, I'm just going to scroll down here, copies a real life database with the correct size. And I'm going to mark it somewhere here, 13 gigabyte, with some number of unaccounted space is about 400 megabyte. The first version of the visitor pattern leaves quite a bit of an unaccounted space behind. In fact, the final output is double. So I repeated this experiment several times. I don't find an explanation for it as of now, so that leaves it as an open question. Nevertheless, you can repeat the experiments once you downloaded the material from my GitHub page and see how actually, whether you can confirm it or not. So just to reiterate, there are two solutions here. You will find two solutions on the GitHub page. One of them with a recursive copy, in a sense that using a visitor pattern, as you can see the H5O visit, and an alternative one, which is the traditional approach, is provided I will be able to click on it, is a much terser property list approach. And toying with both solutions, I do recommend the property list approach, which is the matching with the original H5 copy C implementation, except the lines are denser. However, in some cases, you might have to resort with to the visitor pattern, and here's the code for it. All right, so that's all that I actually have to say about copying objects in with C++, considering the HDF5 data systems. There are many details that you can go into, attributes and whatnot. But generally, these both code snippets properly handling all those angles. I'm not sure, Gerd, if you have any questions or any observations by looking at the very fresh results. But here it is. And this is how far you can take regular C code into a much denser, similarly performing C++ code that can be compiled to most architecture. And most importantly, you can use it both in the serial version as well as in the API version. So if you don't have any questions, that's one of the things that comes into my mind. And why would you pick the second version where actually using the visitor pattern, provided I will be able to switch over to the screen. Oops, this one is the property list. This is the visitor pattern. Well, one of the things that comes into my mind that it allows you to process the actual job right here, or factory out the actual copy or action, so to speak, and possibly parallelize the execution, whereas in the former one, it will the execution is already fixed within the H5 copy object copy function. Probably it will be an interesting exercise to provide an MPI version of the same copy and then see how it scales. But most importantly, first I would look into try to find the reason why it actually ends up with double of the size than it's supposed to be. So that's, I think that covers the question, Gerd. I'm not sure if you have any observations or.
No, I'm good. If you hand me back to screen, we have a question in the chat that I would like to come back to.
Stop share, I suppose.
Yes, I'll go back to my desktop. We have a question. So maybe before we come back to that question, just some sort of parting thoughts on Stephen's, the way he presented it. I would like to point out that copying can be tricky business depending on how selective you want to be. So if you want to do an all-out copy, or you want to say, I only want to copy groups, or I only want to copy data sets, pretty much flatten my structure, that's pretty straightforward. But and that's where the visitor pattern sort of comes in. If you want to be more selective, like let's say you want to copy only objects whose link name starts with an A, and only of those you want to copy them with the attributes, whereas the ones that start with a B, you don't want the attributes. So I don't know why you would do that, but it can be arbitrarily complicated. And then you definitely need the visitor pattern, but then you will have to write a lot more code. But in any event, I would also recommend, just to understand what the ins and outs of H5 copy are, I would recommend play with that H5 copy tool first to just get a feel for it. Okay, so the question that we just got in the chat is, somebody says he has 7,000 HDF5 files, each 500 megabytes. When I use them, should I open them selectively when I need them, or is it advantageous to make one big file or to open virtual files? I'm interested in the speed of the different approaches. Yeah, great question for this clinic also. Of course, it's a question that sometimes begs more question. I would say it depends. It depends, for example, when you say you use them selectively, and you should unmute yourself. We don't have to do that all over chat. Open them selectively. Is it typically less than 10% or less than 1%, or is it more like 80% that you open selectively? That would be one question I have. Another question would be, in what kind of storage are they located? Are they on an SSD somewhere where that's pretty fast, or are they on a network share, or things like that play a role? As far as
would be 10%, and it's stored in one of these boxes where it says, I think, 40 megabits per second.
I see. Right. Well, in that event, of course, if you wish, the metadata traffic, so the traffic related to locating the file, opening the file, navigating inside of the file, that is pretty, that can be pretty intense. On the other hand, sort of transferring, and then of each of these 500 megabyte files, are you reading the file pretty much in its entirety?
All of it, yeah.
All of it. Okay. Well, then it might be
only one tenth. There are 10 data sets, and each will be read entirely. Each of the 500 megabytes is 10 data sets, and it reads one of them.
And is it, are these data sets laid out contiguously or are they chunked?
Continuously.
Contiguously. Well, that's great. So, well, just sort of over the thumb, what I would think you might do is, for example, and so let's assume that inventory is relatively stable or growing slowly. What you could do is to give you sort of this more direct access is you could create what you call here a virtual file. So I imagine by virtual file, you mean something like you have sort of a stub HDF5 file that is very small and contains external links to these individual, to these 7,000 files. And what you could do is you could add a little more metadata to that. For example, since the data is contiguous, you could pretty much store the offset in the file to the respective data sets. So you would have 10 such offsets. And then read, assuming read is the dominant workload here, you could then just read a contiguous 50 megabytes pretty much in one shot and uninterrupted. You don't need even the HDF5 library for that, assuming that since it's contiguous, there's no compression or anything like that. If the data type is just floating point integer or something like that, so you don't need sophisticated type conversion along the way, I would think that's the fastest. And then you can sort of read this, this stub file, what I would call it, just since it's going to be very small, you can read that in memory pretty much and keep it in memory. So then if you alternate or iterate over these files, you have the metadata already there and you know exactly which file and which offset to go to in that file. And that's probably as fast as it's going to get.
Okay, thanks.
Did that make sense? I mean, I'm happy to follow up with that, or I can explain. I will definitely spell out what I just said in the notes, but just let me know if that didn't address
can I
the
ask?
issue.
Right. What is the current throughput on this operation? Do you happen to know? Do you have some numbers?
So
you have 3 terabytes of file approximately, right?
Yeah.
So how much does it take to transfer?
I don't know yet. I'm just kind of producing those terabytes right now. And then I'm just kind of constructing it. So, and then I kind of, it's a fitting program, and these are 7,000 files, are 7,000 different models. So it will have to call some of them depending on the chi-square fit where it goes, you know. So
all right, I have about 3 terabytes of data set. So it really depends on, for me, where I locate them. So there is one cheap location that's about 150 megabytes per sec throughput on the disk. And don't have a problem there. Now, you can go cheaper location, like about 50, I have a location 50 megabytes per sec, that's a lot cheaper. I don't put too much data there. These ones easy to, how to say, like to fill up the bandwidth. Now, if you have a bandwidth like the laptop that I have here, that's 3 gigabytes per sec, that's much harder to utilize. So you have to do something like parallel approach. And that's how I do it. So parallel file system and parallel HDF5.
Oh, okay.
I'm not sure if you have it right.
No.
And there is a file system that we've been playing with, Gerd and I, mostly me, that has actually this problem of latency. And this latency is very high, it's distant file system. And then we have a slowdown. I think that's all I can.
Let's see, maybe did I capture only part of the question? No. work on it that require a lot of. I still don't understand what is the connection between Python and C++. So C++ does the reading, and then you use something like pandas or H5Py, and you pass the data onto a Python-based tool, or how should I read this?
So this is for X-ray astronomy, that they use a Sherpa Chow Python-based fitting program, and that has interfaces for reading in the instrument response function and so on. And that one then interfaces with my 15 terabytes of data. And you have to read in all these 50 megabyte chunks. So that should not be done in Python, but should be much faster. It has to convolute actually 2 data sets and multiply them depending on the fitting parameters.
Can I take it?
Sure.
All right, simplest way, this is how I do it with Julia, is you write it in C++, then you export it in C, and then you're using the mechanism provided the given language, in this case Python, to call the C export.
So right now I use kind of Boost Python to interface C++ with the Python, with this Boost Python.
Then use it should have a function for C++.
Right. That's probably a good solution, no?
I can tell that because there are problems here. So I am familiar with the LLVM architecture-based approaches on Julia, and they stopped working for a while. It would be not easy for me to correct it. And I am reasonably acquainted with LLVM. So there are little tricks there. For instance, H5CPP is template metaprogramming based. Does Boost Python provide that one? I can't tell at the top of my head. I got look.
And using Cython would not be fast. Oh, that's what I understood, because Cython uses the HDF5 Python interface, which is not that fast, what I understood, but I don't know if that's right.
Look, you take any language, the shim code between is basically a mechanism to provide access to a memory location and a code. So you pass some arguments, and then you hand over the control to the actual code in the memory. Then it does its job, it copies the output to some other location, then you take it off from either from the stack directly or from the heap.
Okay. Unfortunately, I have to tell you that time is up. We scheduled this intentionally for half an hour, not because we are afraid that there would be too many questions, but maybe if you wouldn't mind, I mean, I will include this in the notes, but if you don't mind opening a thread on the forum, we definitely should continue this conversation and explore this in greater detail. For example, I would like to know more about that access pattern and so forth. Interface is one thing, but another thing is also how constraining is that interface sometimes, and not using that interface may open new opportunities. Although in the case of Cython, I'm not suggesting that that's the case with Cython, but yeah, we need a little more information maybe. But anyway, I think.
Thank you so much. Sorry if I asked too much. But that's awesome to have somebody to be there actually.
No problem. Gerd, we lost your sound.
And I thank you again for coming, and there will be another clinic next week, and we would be happy to have you again and more people, and bring your problems, and let's help each other. Thank you for coming again, and enjoy the rest of your day.
Thank you.
Okay. Thanks, Gerd.
Thank you.
Bye.